precautions and making sure that we're wearing masks, we're close to people, and just being aware of our surroundings. So, before I get into kind of the product presentation, I'm going to speak just really briefly on emissions management. So emissions management is a new initiative within BakerHughes, and it's really grown out of our commitment to sustainability and our commitment to net zero emissions. And so a few years ago, Baker made a very public statement around reducing our own emissions and achieving net zero, and also in supporting our customers and partners in doing the same. And so we earlier this summer, we kind of pulled that all together into a work stream called emissions management. And so that's something that many of us are part of, and that's where I sit now. We're focused on being able to kind of help customers along their journey in wherever you need assistance with reducing emissions. We also have work streams focused on decarbonization and things like that. And so across BakerHughes, we offer different products and support for this, whether it's from the HANA team or directly from my product team, whether it's through some of our partners at Rotor Stokes and Choke Machinery, different parts of the business. But as a whole, at BakerHughes, we have a wide offering that will support sort of emissions management overall. And so that's just kind of a brief overview of that, just so that you're aware of it. So just touch on a few key points here around that emissions management piece. So there is some key areas that we feel that we really focus on bringing additional value. And the first being actionable and intuitive data. So just providing graphs and providing data points and things like that doesn't always get you where you need to go. And so we've made a significant effort to focus on ensuring that any information that we're bringing to you is actionable, that it's set in such a way that you're able to take a direct action from it. And so that you have enough information around it, here's the problem, here's the details of the issue, you can immediately go do something about that. So that's something that we focus very, very strongly on throughout all of our products. Obviously, you've made very significant commitments, or serious commitments around reducing emissions, and we recognize that, and we want to be your partner in that. We believe that being able to partner in that way is going to help us to raise confidence in the industry, and also, of course, to enable social risks. Other things to touch on is that we recognize that things like certification and carbon credit trading is a significant means to be able to achieve fair market value for the products that are being produced sustainably. And we have experts in both of these areas that can work through the details of this book. And so just to kind of pull it all together, we apply advanced analytics and automation techniques. And what we're trying to do is work towards safer, cleaner, and cost-effective emissions management. So two product lines that we do this with, the two examples of this is our Lumen and BakerHughes product lines. And so Lumen is focused on methane inspection and monitoring, and BakerHughes is focused on ensuring that your combustion efficiency is optimized. And so in the case of Lumen, we use things like IoT or Internet of Things technology alongside cellular robotics to ensure that we're collecting data in the most efficient and effective way we can. But then we also apply on top of that computer vision and machine learning based analytics to be able to provide information on there's a location, how much is being emitted, and all that as well. In the case of BakerHughes, we use advanced diagnostics and verification to enable you to be able to manage and troubleshoot anything for your flare from a control room or remotely, and ultimately to be able to reduce your emissions and costs. So I'm going to go into some more detail on Lumen, and then I'm going to pass it over to Mike, and he's going to talk more about BakerHughes. So Lumen actually consists of two different products. And so I'm going to start with the first one, which we call Lumen Sky. And this is the one that everyone recognizes as the drone product, if you will. That's kind of the most visible differentiator of it, is that we use a drone or aerial robotics, as I prefer to look at it, because really that's what it is. This is far more complex than just attaching some sensors to a manual drone and going out and flying. We automate the whole process, and the team has just done the most phenomenal job in ensuring the robotics side of this is working properly. So if you were to have us come out and use Lumen style on your site, it's a different process than what you might see from some of our competitors. So what we're going to be doing first is we do the onboarding process. And we use it's actually a certificate that we've developed in-house to be able to do this. And so what we do is we fly to the sites and we create a highly detailed model of those sites. And we do this for every individual site. And so when I say highly detailed, I mean, we are including in there an embedded equipment hierarchy for every site and geo-reference component locations. And so as we create the model, the analytics in the back end automatically identify this is a tank, this is a valve, and then we geo-reference each of those locations. Because believe it or not, if you just get a picture of like the top of the tank with the valve, it's hard to sometimes remember which site that's coming from. And so we remove all of that. And when you log into the platform, I mean, it's a bit small, I know, but that is actually a model from our platform. You can zoom in, you can zoom out, point, click, there's a ton of functionality within it. And that forms the basis for us to be able to provide the actual emissions inspection. So that's step one. Now, after that, we then apply another sensor kit. And this is the one that includes the optical gas imaging camera. This is, of course, OGI is, of course, approved by EPA for use with Quad OA. And so we do have that, and we are able to provide that information to support the Quad OA reports. And so if we were going out, say, for example, every quarter or every month, because we've got this highly detailed model of flight paths, that's all generated as well. And so every time that we go out there and we fly that site again, we fly it the same way over and over again. And so the data that you're collecting is very consistent with every inspection. Okay, and this is critical because this is what enables us to be able to provide additional value like quantification with plumes and things like that. So we've developed methodology that enables us, it's based on a computer vision, that enables us to quantify what's the actual fluid from that plume. And so what does that do? Well, what you start to see is that quarter over quarter, you start to build up your data. You start to see, okay, you know what, Bernardo valves or, compressor stations. You start to, or pardon, compressors. You start to see where is your emissions occurring, where is the majority of the emissions in terms of volume, right? Because you might have a ton of emissions from one of those places that's very small, or you might have a high volume. You're going to see all of that. We can pull all of that data out in our reports and the functionality that we have within the platform. And so,
autoplay that one.
Are you?
You're
speeding me up. So again, on the right there, a little hard to see, I know, but what that actually is on the left-hand side, that was a quarter one reports, and on the right-hand side was a quarter two reports. So you can see that, they had much higher levels of emissions on one component type. In Q1, they reduced that in Q2, but they identified that there were some challenges in some other areas. And so because, again, we're collecting that data very consistently over and over again, you see what's on. You can also start to say, yes. We have a ground-based weather station as well.
So you're recording temperature, wind direction, wind speed.
We record wind direction and wind speed at the weather station. We record temperature, not on the weather station, but differently. We have to be able to record the temperature because of the OGI camera, so we have to.
And do you now put a database that we added to, so whatever you find, data on what was found related to that specific action?
We have the ability to add like repair notes and all of that information in there. Yep. So you can go in, you can put comments in, you can mark things as repaired, mark things as under new or something like that. There's functionality within the platform to be able to do that. Yep. And it all you can present all in reports as well if there's people in the field that just want a PDF report. No problem at all. So yeah, I'm just going to finish this one by saying that it gives you a chance to start to identify where the most common problem areas might be, And so then, perhaps you've got a site that's not showing that issue yet, but it might be a good idea to maybe start to look at that and proactively make some changes. So just quickly, this is just a case study. So this is a customer that we work with, and they asked us to do two different types of inspection, well, an inspection and a survey, really. So we do, what we call the large area survey. And so this was, that was voluntary for them. They weren't required to do that, but they wanted to do that. And so we did a quick flight, takes a couple of minutes over each of the sites. We fly at a higher elevation, and so, we're still able to pick out quite a few things, but not as detailed, or, the inspection for the permit for the EPA quad-away piece. And so we did that for some of their sites, and then they also had us perform the quad-away inspection. And so that's just some of the services that we were able to offer them with. All right, and then my second product in the product line I want to talk about is Lumen Terrain. And so this one is, it's our low-cost continuous monitoring approach. So this is an IoT type product. And so what I mean by that is that it's no different than you might have in your home or something like that. So I can, we can attach up to about 20 to 24 nodes per base station, where the base station is just a piece that communicates with the cloud. And so what that means is it enables us to be very, very adaptable and very scalable in how we apply this product. So, we can apply the same kind of system with more or less nodes from, a production site, a compressor station. I've got installations on gas plants. I've got installations on a wastewater treatment plant right now. All kinds of different things. And we don't have to change the fundamental product or anything like that. To do that, we just look at each of the sites and then adjust, the number of nodes and how we place them to accommodate. So very, very flexible in that sense. Nodes transmit to the base station. That all goes to the cloud. So whenever all our analytics is done post-process in the cloud, and this one as well. And so when you log in, you're going to have a chance to see an overview of the site and then drill into each of the sites, see the data. There's the ability to print out reports and all the rest of it. We offer alerting, and so you can set thresholds if you want to be alerted, for example, to an emission above a certain, I'll say 100 parts per million or something for a duration of time. Then we would send an email alert anytime it exceeds that. We would also show the expected location of that emission, and so you know where to go from. So it's not, this one here is much more at that site and equipment level. If you're looking for a very specific, detailed component level, then Lumen Sky is fantastic for that. It's got that visual aspect, of course. Lumen Terrain is more on your site level, and so it's, as I said, a low-cost approach. It's there all the time, that alerts to any issues, and will tell you where the problems might go. Is there a question about that?
Yeah, I'm just curious about how does that data set off the site? So many facilities have restrictions about use their data or network, or is it all facility based, I guess?
Yep.
Okay.
Yeah, so it's standalone, so we don't require any access to your IT or anything like that. There's no firewalls that we have to get through. It's all separate.
Huge.
Yes. Yeah, no, absolutely. It is solar powered as well, and so we don't need to access site power for that. So just quickly, one thing I want to touch on before I think we start to move on here that's really critical of this product. So these are point sensors, and so for anyone who's familiar with point sensors, the nice thing about point sensors is that they are a approach, very durable technology. It's been around a long time. The bad thing with things like point sensors is that you need the wind to blow in the right direction, or you're going to, right? And so what we've done is actually developed software that enables us to model every site. And so we upload satellite images, and we're able to, from the satellite image, identify where the equipment is and the most likely sources of emissions. And then what we do is we run an analysis and predict where we need, or I guess a place where we need to put each of the sensor nodes have the highest probability of detection. And so we can do that for different flow rates. We can do that for different sites. And what's really interesting with this is, a lot of people that are looking at this, they might think just put, 4 out, 1 in every corner, or, it's put it downwind of the predominant wind guide, But we look at years when we do this. So the program models all of that. And what it spits out for us is often counterintuitive, you know, it may not be exactly where you would have thought to just put those sensors, if you were just looking at it. And that's just due to the historical weather patterns and the specifics of your site. And so that enables us to kind of optimize that performance versus cost curve. And so we ensure that we're placing those sensors where at the highest probability of detection, we're going to be able to collect the most data for you and get the highest performance from it without costing more money. Now that's you do it from there.
Okay.
Oh, there we go. All right, so just briefly, just wanted to touch on this. This is something that we're very, very proud of. So there's a press release that came out earlier this year, and one of our customers elected to work with us on their certified gas project. And so that is our Lumen turning solution that is installed at that house.
Not the important stuff.
Flare IQ, was that too long?
It's always too long. No one wants to wait for Flare IQ. Thanks, Myalee. I think that, just for everybody, we're going to be going a lot more in depth into each one of these solutions a little later today. But if you have any questions now, you know, please feel free to ask them now. You know, it's always an open forum in here. So we've been here in the past few years, delivering that jump Flare IQ. It was always tied to the RSR regulation, the 270 BTU per scuff, the smokeless operation, all of these things. And it's a great solution. But now Flare IQ has grown into more of a platform for panometric. You know, the first step is obviously the RSR, the flare control version, which you're going to hear about. Sue is going to present to us in a little more in depth. Then we've got our digital verification or advanced diagnostics program, which Victor Tafoya will be presenting after that. And we actually do a third version where it's called combustion efficiency, where we're not going into that today. It's primarily for the upstream space. What it does is it gives real-time combustion efficiency data to you. And we live in an era where data is important. You know, it allows you to make better decisions, and getting frequent data points allows that. Current technology that's in place, you have different lag times. And so that's where the Flare IQ is really making a difference in industry when it comes to emissions management and you know, addressing the climate change issue. So this is the basis of pretty much all of our discussions today when it comes to Flare IQ. So Sue will dive very deeply into this, but I'm just going to sort of go over the basics on it. And while Myalee, you know, was standing in the middle, I tend to pace around, so I apologize if I get into your sight line.
I just got a trip.
So this is a generalized schematic for flares in downstream or petrochemical plants. It's not all, there's always, you know, every flare is a little bit unique. So the main thing is, you have your vent gas line coming in here. Hopefully, at this point, you have a panometric GF868 flare flow meter in place. But after that, we just hope we can have an ultrasonic meter as a technology. The BTU front end, this can be calorimeter, this can be a GC, it can be a mass spec. The difference between those is well documented in some of the other sessions here. But a GC and a mass spec provides you with speciated data, so you know exactly what's going through your line. The downside to GCs especially is that they take 6 to 10 minutes to refresh their data. And I would say if you want to strike fear in a controls engineer at a refinery, is tell them they're controlling their safety system, which the flare is, on 6 to 8 minute old data. And that'll strike fear in their eyes. And what Flare IQ is, that gives you much more frequent data on it. You have a fuel gas line, supplemental fuel. This is to meet RSR's 270 BTU per scout. Usually this is a 1.5, 2 inch natural gas line coming in. Flow meter can be ultrasonics. We'd love to supply you with ultrasonic, but oftentimes it's a different technology for the flow. As long as you get your accuracy, you're fine. And then a flow control valve. As BakerHughes, we're going to promote the Mason-Nealon product line for control valve, but every state will have their own approved vendors. And most important, or most interesting, not the most important part, but the most interesting is your assist line, your steam or air assist. So what the assist does in a flare is it really promotes mixing of your system. So that provides smokeless operation and better total combustion by your flare tip. And so you have a hopefully ultrasonic, panometric ultrasonic steam meter in place here for good turn down ratio and also a valve. Now when it comes to these two additional lines, if you want to increase your BTU content, you add gas. If you want to make sure it's smokeless operation, you add steam, but that reduces your BTU content. Okay? So managing this is a real balancing act. And there's something that most plants refer to as your steam to vent gap ratio. Most places, it's a standard 1-to-1 for every pound of flare gas you go through, put a pound of steam into your line. It's great most of the time until you have a process upset, where your molecular weight changes, you get a bunch of black smoke, and so then you start cranking up the steam, which means you have to crank up the fuel gas. All in all, it's not an optimal situation. So what Flare IQ does is it communicates with your DCS, and it provides you with optimal steam flow as well as fuel gas to balance that out, sort of ride that the razor's edge when it comes to maintaining your 270 BTU and smokeless operation. And most importantly, after your process upset is done, it reduces your steam back down. So many times, you know, process upset, the operators will put the steam on to make sure that you get away from any black smoke, and they never turn the steam back down again. So, that costs money, and we're in tough times right now in the industry. Every facility is trying to reduce costs. So every dollar you can save is a big benefit. And I'll get into a little bit of that, the preview for today's discussion. But when it comes to combustion efficiency, we're here because we're all environmental professionals. Combustion efficiency or destructive and removal efficiency is something that's important. Now, I think I've seen some of these are familiar faces from previous years, so I'm not going to ask anyone specifically, but you got 4 flares here, 4 very different combustion efficiencies. They're actually all the same flare, to be honest. And by the naked eye, we can't tell which one is the most efficient. Here's the brain. I think we can all agree on first glance, this one, pretty horrible, right? But then most people, will eliminate this one too, because that's not a healthy look plant. But between these two middle ones, one is compliant and one is not, and you can't tell by the naked eye. And so, up here, this is the compliant one when it comes to RFR. This one looks great, no black smoke, perfect, but there's 10% methane is escaping uncombustible. So this is where having advanced diagnostics, advanced tools to be able to do this is important. And a camera system, there's lots of vendors out there with infrared cameras. Avitas uses infrared cameras on its own. It's a great solution, for this. However, when you're dealing with a line of sight measurement, you have bad weather. If you have snow, rain, that data is not going to be there. So we need to do an in-pipe measurement to provide combustion efficiency, take into account the weather conditions and all of that. So what can this mean to your facility? Time checks I tend to talk a lot. So I'm only going to focus on refinery one. So if you go with these advanced diagnostics and control schemes, you can see they're running 200,000 standard cubic feet per hour through 3 flares. Before the flare IQ, they were putting in 7,400 pounds per hour of steam. We all know the flare tips usually require about 250 pounds per hour of steam just to keep it cool. So after we put flare IQ in, with 3 flares, they're at 250 pounds per hour minimum. We're actually only adding an extra 30 pounds per hour of steam to maintain compliance. What that translates to is going from 85.5% combustion efficiency to 98% combustion efficiency, and at 58 million pounds of steam per year in savings. If you go to a powerhouse engineer at a refinery and say, hey, can you use, if you had more steam available to you, could you use it? Most of them say yes. What we're doing is we're reducing the load on the boiler system by 15 million pounds. And if you put a dollar figure to that, we put $6 per 1,000 pounds of steam is the cost to generate and transmit that. It might only be 5. You know, we're putting together some good numbers here and trying to make it look good. But at the very minimum, it's be $4 per 1,000 pounds. That's the absolute minimum. So at $6 per 1,000 pounds, $350,000 per year of savings. Now the cost on this, the return on investment is about 8 months. And then all those savings are to the refinery at that point. It's very significant. And this is an area that most refineries and petrochem plants don't look at because they've already bought their boilers. They've already got this in place. But as you expand and you look at the load demand, it's a good way to reduce CapEx costs in the future. So, and we're all environmental professionals. We know CO2 equivalency, we know carbon taxes are coming in some form or another. There will be costs. By going from 85.5% combustion efficiency to 98, not only are you compliant, but you're also saving in metric tons, 62,000 metric tons per year. Average, carbon tax in Canada, I think is at $20 per metric ton. I think in Europe it's around the same. If that were to put in place in the US, $1.2 million savings right there. So we need to prepare for the future. We all know that this sort of thing is coming. So now is the time to not just be compliant with RSR, but to move forward and get ready for, by 2030 when there's various taxes. So, all right. The other thing that I want to talk about, and so we're going to talk about more on how we do that. Lay is going to be talking a bit more in depth on that. And then Victor will come on after that, after lunch, and talk about our verification. If you have a panometric flare flow meter, I know a lot of the people here that I talked to briefly beforehand have got meters in place and have service agreements in place. Our traditional way of doing a verification, we recommend annual verification, is you do ex situ. This is where you go to, our engineer goes to site, physically pulls the probe out of the meter with our isolation valving, puts it into a zero flow box, and what we call, it's really the single point calibration. We as a company, we don't call them calibrations because calibration is multi-point, a lot more detailed, but we call them verifications, and that's accepted by the EPA. And the single point, and we put everything back in. We can do about 1 meter per day like this. It's very labor intensive. It requires trades at your site. You need a fitter, an electrician, sometimes supplied air, in order to do this. Very costly. If you go under a service contract with us, usually a 4 or 5 year agreement, which a number of you have, every other year we can do an in situ verification. So for this, we go out physically to the electronics and do diagnostics from there. We don't have to pull the probes out. It's a huge cost. Also, we can do about 3 meters per day. Now with that, it's much quicker, when you don't have to involve the trades and supplied air. And this has been great for the last, 5, 6, 7 years. We've been doing this, and it's great for the industry. The next step is digital verification. So this is where we install a Flare IQ box, we connect it all, and from the safety of the control room, our engineer can do the verification just on demand. Provide you with the full report that's required, but there's no need to even go into the operating unit. So obviously this is the safest. We joke around that our engineers can go in khakis and a polo like Jake State Farm, and do a verification. But in reality, they're showing up with their FRs in case there's a problem and are ready to fix anything. For myself, I think that's great. The service team loves it, the service group. For me, the most important part is if you have a process upset, let's say you run 200 feet per second through your flare line, and everything's come back to normal, everything's fine. You're not due for your verification for 6 months. You're not going to call Panometrics up and say, hey, can you send somebody out just to make sure this thing's working right? You're not going to do that. But what digital verification allows is for you to do a verification on your own, on demand, with just phone support. You need to do it on your own, but in order to interpret the data, phone support, is usually really good, but it gives you peace of mind to know that your flare meter is back online and operating as it should. But if you run 200 feet per second through a line, there's damage done somewhere to your line, whether it be just, to, a thermal well that's in place or possibly to our transducer. You never know what's going through the line. So, and Victor will go into a lot more into how we do that and how we're able to say that this is a legitimate verification according to the EPA. That's what we got for an introduction. Any questions for me? I know we're going to go more in depth, but I'm more than happy to dive a little bit deeper if you have any questions now. No? Any one of the green shirted people have a planted question that they want to ask? There's a number of us here. But no, seriously, thank you all for joining. I think we're probably going to take about a 10-minute break. And then Lacey is going to come on and talk a lot more in depth about how we do this, through the Modbus mapping and all of that. So, all right, thank you.
To see how to connect everything.
So no, just email it.
Email to you?
Email it to this computer. What's your email address? LEI
I was just saying.
at Baker.
At the BakerHughes.
Okay. So just reply to that email that I'm gonna send to you with the presentation, then I'll upload it.
So, yeah, we're.
We can scan these things. Can't we?
Yeah, I scanned it.
Yeah.
My LinkedIn came up.
Holterman's
So, come here.
What do you want me to put lipstick on?
Card.
Do you have a card? I was just saying, I don't have any cards because we haven't, visited real people.
Oh, I thought you were asking for the scanning too.
And also we can.
Yeah.
So my
scan
title's
stuff.
changed with the phone contact all. Yes,
Alberta or what?
Ontario. Here.
Oh, excellent.
So I have a friend that works at Solvay, she's the quality manager at Solvay, Niagara Falls. She works at Green Mountain.
No, we have the other presentations. Oh, so you'll, okay.